So, my dear students, my today's topic is how to deal with imperfect squares. So, before knowing about imperfect squares, it is very important to know about what are the perfect squares. Let's recap. I hope all of you are well aware about the perfect squares. What are the square numbers? Square numbers are those numbers which can be arranged in any square shape. For example, if I have a number 1 and I make one square having a unit 1, for example. So if I arrange it, definitely I'm going to get a square in the end. Now see, 4. If I have a number 4, what I'm going to do? I'm going to make 4 small squares of unit 1 and I'm going to arrange them. Once I'm going to arrange them, I see that it's forming a square. Moreover, if I have number 9, I'm going to make 9 small squares and I will arrange them. Once I'll make the arrangement, I will see that I can arrange it in such a way that its number of rows and number of columns are same, which mean that it has two dimensions which are same. So I have formed a square. So all those numbers whom which we can form a square are known as the square numbers. Now, what are the perfect square? Let's learn the proper definition. The numbers which is a square of other number. For example, if I multiply 0 with 0, the answer is 0. So I multiplied a number with itself, and the number is that number which is the result is basically the square of that number. Similarly, if I have 1, if I want to take its square, I'm going to multiply 1 with 1 and my answer is 1. Similarly, 2, 3 and so on. So what do I get over here? I get that 0, 1, 4, 9 are the perfect square numbers. Now, a very hint. If is a number and somebody asks you tell whether it is a number perfect or not, what you're going to do? You'll simply check its unit place digit or last digit. If the last digit is ending at 2, 3 and 7 and 8, you'll say it is not a perfect square. But if it's ending at 1, 4, 5, 6 and 9, you say it may or may not be a square. You have to check it. But for 2, 3, 7 and 8, you can straightforward say that it's not a perfect square. Now, here comes the question, what are the imperfect squares? As I told you, today we'll be learning about the imperfect squares. So imperfect squares are the numbers whose square root contain fraction or decimals. Or if you take its square, you don't get a whole number in a result, right? For example, as I told you, 4, 9, 16 and 25 are the perfect squares because their square roots are 2, 3, 4 and 5. But the number 2 and 3 are not the perfect square because if you take their square root, there won't be a whole number. Now I have a question for you. Is the square root of 22 rational number or irrational number? For that, what you'll do, you'll find the square root of 22, which is not a rational number because there is no integers which multiplied with itself gives you 22. So this is not a perfect square. Now how to check whether a number is a perfect square or not? By guessing? No, not at all. What are you going to do? Sometimes it's very easy to guess because some numbers, like once you are studying mathematics, you're a student of mathematics, some numbers are very easy to know and learn because we use them frequently. But once the number gets bigger and bigger, it gets harder for us. So in that case, what you're going to do? Will you guess? Not at all. So what you're going to do? Mathematics is nothing but all about logic. So a logical way to check whether it's a square root, the given number is a perfect square or not, what are you going to do? You're going to check its square root by prime factorization or division method. Now, what if somebody asks you that the number is not a perfect square? How can you make it a perfect square? By multiplying or dividing it by some number. What you will be doing, the process, the way I'm going to tell you is that if number is a perfect square, if you do its prime factorization, all of its factor will be in pairs. But if it's not a perfect square, its prime factors will not be in a pair. Let's see an example. Is 90 a perfect square? Now I have a question for you. How are you going to do it? What are you going to do it? You will be solving it in a way that first of all, you will be going to find its prime factorization. Once you do its prime factorization and you mention all the factors, prime factors, you see that 90 equals 2 times 3, which times 3 and times 5. In this you can observe that 3 is in pair but 2 and 5 are not in pair. So this shows that the given number is not a perfect square. We can see that 2 and 5 are not in pair, so 90 is not a perfect square. This is how you're going to give the answer. Now another question. My question first says, is 2, 3, 5 a perfect square or not? Second one, find the smallest number to be multiplied with this to make it a perfect square. The last one, the new number which you're going to get, see whether it's a perfect square or not. So how are you going to solve it? To check whether this is a perfect square or not, first of all, you're going to do its prime factorization. Once you do its prime factorization, for the first part, you can see that you have one pair of 2, again a pair of 2 and a pair of 7, but 3 is not in a pair. Since this 3 is not in a pair, this shows you that 2, 3, 5, 2 is not a perfect square. Now how you can make it a perfect square? By multiplying it with some number. For that you can see that 3 is not in a pair. If 3 was in pair, the given number would have been a perfect square. So what you're going to say, that in order to make it a perfect square, I have to multiply this with 3. Now again, finding the square root of 7056, the new number becomes this. If you find its perfect square, that comes 84. And now another example. Again, question is, find the smallest number by which this be divided so that the quotient is perfect square, and find the square root of the quotient. First of all, definitely you will be doing the prime factorization of 9408. What do you observe over here? You observe that it has 3 pairs of 2, 1 pair of 7, and 3 is not in a pair. So what you're going to do? You will say that in order to make it a perfect square, I have to multiply it with a 3. Divide it by 3. Once you will divide it by 3, the new number becomes 3136, and definitely new number will be a perfect square. So you're going to say that the smallest whole number to be divided is 3 and the new number square root is 56. Case 2. If there is an imperfect square and somebody asks you what should be added or subtracted in it to make it a perfect square, what are you going to do? For that, you will be doing this, finding the square root by division method. Once you do the square root by division method, you observe that if the remainder is not 0, the given number is not a perfect square. If remainder is 0, definitely the number is a perfect square. That is a way to check it. Now, if I ask you find the least number that must be subtracted from this so that you get a perfect square, also find the square root of that perfect square. What you will do? First of all, you do the square root by division method. What do you observe over here? 131, which is a remainder, not 0. This shows that the given number is not a perfect square. Now the question arises, if this is imperfect, how are you going to make it a perfect? For that, what you're going to do? You're going to subtract 131 from the original number and the resultant will be a perfect square, as you can see how it is done. Now another question, what must be added in a number to make it a perfect square? For that, whatever the number is, do this, find the square root by division method, and in remainder you get 4. Since remainder is not 0, which means this is not a perfect square. Now what are you going to do? You observe here that the given number is bigger than the square root of 36 because it has some remainder in it. So you just focus on what is the next whole number. Here the next whole number will be 37. Take its square and subtract the number from it. Once you subtract, you see that 69 must be added in it to make it the perfect square of the next whole number. So here we have 1369, the next number. Now you check it and you see whether you get the remainder 0 or not. Yes, you got the remainder 0, which means that you have formed an imperfect square into a perfect square. So guys, this was our today's lesson, how to make an imperfect square a perfect square and how to guess whether the given square is a perfect or not.